So, good morning. We've been doing MATLAB programming to implement the Gauss-Seidel method. And the goal today is to complete this program and have some discussion. And by the end of the class, we hope to upload your MATLAB code to to Canvas, which will be counted as participation for this module. Okay. Now, after we finish implementing this program, I would like to get some volunteers from among the audience who have their own program either already done or done during this session to share their screen and we could have some discussion. Just some few examples of I'm showing you how I would implement it. I want to see how you implement it, some of you, so that we can get a sample of different viewpoints. Okay. So if you haven't been doing this or if you weren't here last lecture, we did this programming and I posted the script here in Canvas. You can just copy paste this onto a MATLAB file and continue with us. Okay, so we got up to here. So we just stopped there and now we are going to continue. So I'm giving you a minute to catch up. Copy the script, go to Canvas, copy this text file, open the text file, copy the text, put it in your MATLAB. And if you hit run, it will not run correctly. It will just compile. And now we'll continue from here. So 1 minute for you to catch up. How many of you actually like this programming exercise? You can be honest. Okay, good. Thank you. How many of you think I care? I care about you liking it. Okay, it's important because I know I can now spot who is actually engaged with the class and who is kind of here because this is a required class. I understand you have to take this, but if you at least get over your inhibition, you will actually see that programming has a lot to offer you beyond the classroom. It's a way to think. You have a busy day, you wake up, you have a 2-year-old, you have a broken garbage disposal, you have to get here. It makes you think, it makes you plan your day, and you can actually get by life a little bit easier if you think algorithmically. That's what I'm trying to say. Okay, so don't detest it, embrace it. All right, are we caught up? Can we continue? So to recap, we input the coefficients A1, A2, A3, A11, A12, and so on. We had a tolerance chosen. We are putting an initial guess, and then we are starting the iteration. Now, I told you that to start the iteration or the while loop, we want to keep computing or doing iterations until our chosen error criterion remains above the chosen tolerance. Okay, so we give the error a high positive value, which will surely be higher than the tolerance. All you need to do is initially this number has to be greater than tolerance for the compiler to get within this while loop. And this while loop, this block of code will keep running until the error remains greater than tolerance. That's the condition. Okay. So now we first computed the values of x, y, and z by inverting each equation. Equation 1 for x, equation 2 for y, and equation 3 for z. And then at the end of each calculation, that is after line 49, the value of x would have changed from your initial guess to whatever that value is. And your value of y would have changed from your initial guess to the new value at the end of line 50, and the value of z would change after line 51. Okay, so just to see this process, okay, I'm going to have a counter. I'll call it iter, and I'll give it an initial value of 0. Okay, so an iteration counter. And then after I'm done with an iteration, what should I do? I should increment my counter by 1. It's like having a clicker in your hand and saying click 1, click 2, click 3, and so on. So one iteration is done, I update my iteration counter. So now I need to evaluate my error so that the compiler can check it against tolerance and decide whether or not to continue doing more iterations or continue with the next iteration, not more, but just the immediately next iteration. So let's write a statement. Error equal to, we need to punch in a formula, okay? Now, last lecture, I talked about different ways of computing this error criterion or different ways of coming up with an error criterion. I'm going to use the annotate tool here to just write it out. So I'm going to write, I'm going to try 3 error criterions, okay? I'll call it error 1. Error 1 is max of EX absolute, EY absolute, EZ absolute. And what is EX? EX is X minus X previous. This is the first criterion you are going to implement. We'll do 2 more, okay, just to get you some variety. So now we are storing, or we are just directly using the values of X, Y, Z. So we don't distinguish between previous and current. We need a placeholder that can hold the previous value before it's forgotten from memory. You need a placeholder. So I'm going to define a placeholder and call it, say, for example, X previous. And X previous, what is the statement? It's just going to be equal to X before it is updated. There is X previous is equal to X, and it is placed before it gets updated, before X gets updated. So I'm going to add a comment and say X previous is a placeholder for the current value of X before it gets updated. Similarly, I will do that for Y previous equal to Y, Z previous equal to Z. It's a placeholder. This 90 minutes or so, you actually stick with me and do it as we do it on the board. And I promise you, you would be able to compile a successful code. This is not the time to check your phone, your emails, your Facebook profile or anything. Focus, okay, just 90 minutes. I have had senior colleagues who make it compulsory. They ask you to leave your phone outside or laptop outside or whatever. I'm more cynical than them. I would actually make it difficult in your homework and exercises if you had not focused, rather than asking you to focus. So please. All right. Now what? What do we do now? We need to compute this EX value, right? You want to compute? We'll call it, say, error in X, and that is equal to X minus X previous. I have error in Y equals Y minus Y previous, and error in Z being equal to X, or Z minus Z previous. Compute absolute error for each variable as the difference between current and previous. Just absolute value, sorry, not absolute, yeah, absolute error, that is with the sign, it has a sign. I'll just remove the word absolute because it can be confusing. I'll say compute error for each variable as the difference between current and previous. So now, if I call this itself. Now, if I call this first criterion that we are going to explore as say E1, I want you to punch in the formula for E1, just whatever you can try, and then I'll show you the syntax, because also depends on you knowing MATLAB syntax, which is actually pretty simple. You try. You can literally put this, and I think it will work. So I want you to do E1 equal to something. Fill it up. You can literally type in max. I think max is a function. Yep. Absolute value of error in X, comma, absolute value of error in Y, comma, absolute value error in Z. Or I should check if this is the syntax or ABS is the syntax.
ABS.
ABS?
ABS didn't put the little red squigglies.
Okay, so it's probably ABS. ABS. ABS means absolute value of the whatever the argument is. If it's a real number, it's the value without the sign. If it's a complex number, it's the magnitude x squared plus y, a real squared plus imaginary squared. All right, so you have E1 as max of EX, EY, EZ. And you can, in the next line, line 66, you can write error equals E1. We are going to do more error conditions. Like for example, we'll have a E2, we'll have a E3, and so on. So let's catch up up to here and then continue. If you need any help, please ask. I'll be happy to walk around and help you. The TA could also do the same. This assignment is not like a competition. I just want you to try. I'm giving out all the steps. There is no mystery, no tricks. Just do it, get a working code and upload it. That's it. Yes,
You don't mind if we upload our own code, doesn't be.
that would be very appreciated. If you wrote your own code, please, I want to see it. If you are working off of this, that's fine. Yes.
When we run it, why is it giving us errors in the E1 line? E1 equals max ABS. When we decide to run it, it gives us errors on the line.
Okay.
Will we check it out?
So maybe it considers the so with MATLAB, the good thing is you have excellent documentation. So if you go to the function help center and type max, you can get description of what that function is supposed to do. So it says max of A returns the maximum elements of an array A. So maybe it expects you to provide the argument as an array, okay, which you can easily do. It's not a difficult thing here. So if you go here, let's give a symbol, okay. We'll call it E. Yeah, error in the variables. We'll call it EV. And you can build an array which has elements, error of X, not comma, error of Y, and error of Z. Now you can just, oh, it has to be absolute value. Now I'm just going to write max of EV. Just to create an array of 3 numbers, and then E1 is the max of those numbers. So now I'm going to just try running my program to see if I'm on the right track. Okay. And if I do that, my program finished running. I have to see the output. Okay. So then if I take my X, oh, something's gone wrong. All right. So let's see what's happening here. Okay. So take a pause, look up. We have our program. We have an error criterion. It might not be the perfect criterion, but it should still work. We are computing the error, the difference between current and previous, and the absolute value of those, and the maximum of that, so that this is our condition. As long as E1 is above the tolerance, the program should keep running. Now, surprise, surprise, if I run this program, I'm getting, so if I look at my values here, here is X value. So if your program ran correctly, and after how many iterations? After 301 iterations, the program should have converged, but what we are getting instead is X value says NaN. NaN means not a number. That's what MATLAB denotes infinity. It shows that our solution blew up. What happened? Did we give the matrix of coefficients incorrectly? What did we do? Yes?
It diverged.
It diverged, yes. Why?
The input values will be changed, I think.
The order in which you present the coefficients must be adjusted so that they are diagonally dominant. This is a very, very simple algorithm. The only reason it usually diverges is if you don't present the coefficients in a diagonally dominant form. So look at these coefficients and let's try to rearrange them on the board and then come back to MATLAB and punch them again into that. Okay, otherwise the code should be working. Okay, so before I go to the whiteboard, if you are still writing this these lines of code, I'm giving you half a minute to complete it and then let me know so that we can move on to the whiteboard. If you're finished it, try running your program. It should compile without errors. And after running it, you should see what the output is. In my case, it has diverged, probably for you too. Is anybody still trying to catch up? Is everybody caught up? Yes. Okay. All right. So now let's look at these coefficients and see where we went wrong. If you look at the first equation, that's like writing 8x plus 2y plus 0z equal to -7. The second equation is 3x plus y plus 4z, 3x plus y plus 4z equal to 13. And then third equation is 3x plus 5y, 5y plus 2z equal to 8. You want to look at your diagonal elements and you want them to be greater than the sum of the other two. Does it look like that? For the first row, yes. For the second row, no. For the third row, no. This is the reason for the divergence, and you want to rearrange these equations in a form such that this condition is met for all the rows. That is, for the second row, the condition would be A22 should be greater than A21 plus A23. A33 must be greater than or equal to A31 plus A32. This was met, this was not met, this was not met. So how will you rearrange these equations so that you would have a diagonally dominant system? Sorry?
If we put the one on the bottom and then put the bottom one on the top.
If we put the third as the second and the second as the third, should that fix the problem? Because if you consider this as the second equation, 5 is equal to 3 plus 2, so we would be okay. And 4 is 3 plus 1, so we would be okay. So swap equations 2 with 3 and vice versa. Okay, so now let's try that. Okay, so I'm going back to my MATLAB screen. Whatever was my third equation is now going to be my second equation. Okay, so to improve the clarity, I'm going to write my first equation is what? 8x plus 2y plus 0z equal to -7. And my second equation now is going to be 3x plus 5y plus 2z equal to 8. And I'll accordingly change my coefficients 3, 5, 2, 8. And my third equation is what? Whatever was my second equation should now be my third. 3x plus y plus 4z equal to 13. So I have 3, 1, 4, 13. Please make this change. And try running your program. I'm going to run mine and see what happens. Ooh, look at this. So pay attention for a moment. Look up, please. So I ran the program with my coefficients changed. In 13 iterations, 13 iterations, the error criterion or error went below the tolerance. And then the values of x, y, and z that I got are minus 1.0455, 0.6818, and 0.8636. Of course, if we had done the programming right, it would satisfy these equations. But why don't you take these values, use pencil and paper to check it. If this works out, that means the program is good to go. All we have is a few more things to discuss, that's it. So pencil and paper, plug these values in and check if this is true. Yes. Sorry? Oh, I'll write it out. It's in the tiny corner of the screen. So x equal to minus 1.0455, y equal to 0.6818, z equal to 3.8636. Substitute these into the three equations and check if they match or satisfy. Yes.
I get the little workspace thing.
Oh, so you need to go to the leftmost and you see these symbols here. The fourth is the workspace. Oh, sorry, fourth is the command prompt. The first is the workspace.
Oh.
Let me come over there. So please substitute and check if this is the solution to our three equations or something. So this is your command prompt. You want to see. Let's just put how to bring command prompt.
Yeah.
Because I don't know, maybe if I try 10 minutes, but you can let him. Yeah, he can help you. Yes.
So I'm getting an error on my code and I don't know what I did wrong. I'm getting an error on my code and I don't know.
I get back. What was your question?
Explain what we said.
Yes. I'll
No, it's not.
So when you need the error message, it typically says invalid expression and calling a function of previous. Use parentheses. So which line is line for it? So you are, I think you have an extra parenthesis. Right. The error would have next.
Yeah.
Okay, first,
You need to fix the parentheses. Yeah.
so. Here was wrong, it's something. Just reiterate.
Fall down, please.
But I'm looking to
Yeah, that's fine.
Hi guys.
What was your initial guess?
Yes, there.
I don't have a instant answer for you, maybe sit and think about this. Yeah. Yeah, you can. Yes. But I'm not sure why it ran for 3 iterations before stopping.
Yeah, that, I don't know, cause like I looked at the first iteration, it seemed to be gone.
Yes.
Orange time. The college code, mine, either the next. And I had a kind of like behind, I had an account that was kind of going. Like, why did it not like all those? No, I have. That. I never slow back to the first. Then really first on the so just a little bit.
So. So. Your attention please, yeah. So I see all of you are, or most of you are able to get the program to function and you are getting these numbers, which you have also verified is satisfying the original equations. The key point is, first we tried the same program for the same set of equations, but the coefficients written in a way which was not diagonally dominant. And what do I mean by diagonally dominant? It means the diagonal element is at least equal to or the sum equal to or greater than the sum of the other two numbers without their sign, okay, just the magnitude. If you satisfy this for each row, then you are diagonally dominant. If you don't satisfy for even one row, then you are not diagonally dominant. So if you want a converged solution using the Gauss-Seidel method, before you start punching the numbers into your program, first step is to ensure that you write the equations in the form that they are diagonally dominant. If they can't be written in that way, then you can't use the method. Okay. So if I look at the first equation as written, 8 is greater than 2 plus 0, we are good. As written, if this is the second equation, that is if it is the pivot for y, as written, 3 plus 4 is not greater than 1 or it's not less than 1. So the second equation does not satisfy, and the third equation also, 2 is not greater than 3 plus 5. So the third equation also didn't check the box. But if I swap 3 as 2 and 2 as 3, that is if I use the second equation as the pivot for y, then clearly phi is equal to 3 plus 2. And if they use the third equation as the pivot for z, 4 is equal to 3 plus 1. So we are good. So it's not just important to have the coefficients punched in. Suppose you are asking the user to input coefficients. The first thing you should do is check if they are diagonally dominant. If they are not, you'll have to rearrange them. So you can think about adding more functionality to your code, like getting input from a user, checking for diagonal dominance, and then rearranging automatically to get it to be a diagonally dominant form, and then going through the solution. All that is more lines of code, but the key thing about programming is if you can clearly state it quantitatively, it can be turned into an algorithm. That is the essence of programming. If you can state it objectively, quantitatively, it can be programmed. It will take some effort. Sidebar. How many of you are aware of the Ford plant that is coming up some 90 miles from here? Sure. But the idea is, you're all mechanical engineers, they are going to make cars, so don't you want to get jobs there? But they are going to make electric cars. Okay, so if you just go there with your fluid mechanics and machine design knowledge, not knowing squat about programming and electronics, those electrical engineering guys in second floor, they are going to take up all the jobs. So if you want to have an edge over them, learn programming. You can't program a controller, you can't read a sensor output automatically. You need a notebook and paper to record, do experiments, you're done. You are in 1900s. This is 2023, okay? So learn programming. The reason I'm talking about that here is, this program as it stands now is very crude. It takes input which you have to punch in. It will work only if the inputs are correct. But a good program will also have enough margin for error that any input from the user will be checked for some kind of quality, readjusted so that the program can still function, and try your best to actually give an answer before giving up. Okay, so anyway, let's do one more problem. I want you to use the same program, just change the coefficients to solve another problem. And once you know your programming is working for sure, please upload it to Canvas. I'm going to create the submission link right now. Before 12:45, you are all going to upload it. Now, before we move on, is there anyone who doesn't have a functioning code which can actually give you these numbers right now? Okay, so we need to fix those issues before we move on. Okay, so please, let's take 5 minutes here. Tell me what your issues are, or I can come over there and we can talk. Okay, do you have an issue? You do? Yes. Can you please talk to some of them? This is E1 here, not E1.
Don't play spaces. Now we'll do with the same name. We're gonna save it. Different file name even. Same file name, but instead of spaces. Would you have a name as? That could be one problem. We either do it together or do underscores. Yeah. Maybe just have a hyphens. Yeah. Okay. Try and win that one now. Yeah, that should
These numbers are the beings.
You have this here? Yeah. It's just you don't have it. Oh,
Yeah.
And say. No need.
Okay.
Go down to what the range was with. Yes.
oh yeah, where we say it's not where it is.
So in the last 10 minutes, the problems I've seen are usually typographic errors. You miss something, that's the usual problem. So check for those first. Right? Illegal use of reserved word.
Oh, no.
It has to be A1 times plus A1 3 times 6. What do you think?
Iteration error percentage. Usually these are type of events which
Yeah, but the one that makes one of the decisions would be early. Where it's hiking each and every one of them.
What is it?
When both are areas, automate that. Schools. Try to automate. Think of everything else. Really, it's really just. Change the numbers. No, you do. Well, yeah, yeah. Oh, is that what you said? Yeah.
Did you realize?
Sounds like a horribly sick.
Yeah, do that. You didn't rearrange the coefficient. Make it look exactly like that. A two one to be 3y from 3y, 25 to 8. Take it out. Let's have it the other.
The music.
Just one should be 3. Yeah, so it's not showing any area.
Yeah. One thing that always confused me is why.
You have it assigned twice.
Wow.
Oh, you're here. So your current value. So next value. Doesn't exist. Try that. Say different. Thank
Starting from what?
I don't want to. Yes. Oh, okay. That's good enough. Anyone else has questions? Yes.
Try to write a. Exactly what you're making.
Yeah. Yeah, really, you would just change the agent guide. Yeah. So when you use the max function, usually that says the array. You should have, if the array is say 3 by 3.
Yeah.
You could just have a colon, comma, 1 to 3 or 1 so the syntax is something like this. A of you can just set colon. The problem with that is that it's like if you just want to check setting up the first place, you just take max of this set up 1 comma 1 colon. A of 1 colon. Check only the first 3 elements of the first one. Yeah, you'll have to take it to the document. Yeah.
Choose 0 or not.
Yeah.
Greater than the A, it's 1, gives you 4.
Yeah.
So why is it
The order matters in the sense you want it to be diagonally dominant. That is, when you invert each equation, you are using this as the field. So when you have the equation at the top, that is, your attention please. I got a good question. I want to answer it and I want you all to listen. So the question is, why do we rearrange the equations to make it work? So what, or in other words, why does rearranging fix the problem? Alison, can you pause? Yeah. So we have our equation, let's say A11 x plus A12 y plus A13 z equal to B1. I'm rearranging this for solving for x. So x equals B1 minus A12 times y plus A13 times z divided by A11. This is the equation. Now, if I write this as B1 divided by A11, that's a constant, minus I have A12 divided by A11 times y minus A13 divided by A11 times c. By requiring it to be diagonally dominant, what are we saying? The magnitude of A11 is greater than the sum of the magnitudes of A12 plus A13, meaning clearly A11 is individually greater than each of them. Is clearly individually greater than each of them. Look at these two coefficients. If A11 is always greater than A12, what that means is this coefficient will always be 0. So the weightage of y will be always bounded. It will always remain a number that is less than 1. If this number is greater than 0, think of x equal to a constant plus a couple of correction terms. If your correction keeps on increasing each time, then there is no hope of you reaching a steady value. Your correction has to die out over time. That is what is ensured by making this coefficient less than 1 by requiring diagonal dominance. Because it is diagonally dominant, these values will always converge, and you will get a converged solution for all the 3 variables. If you don't require it, this will keep increasing, making x increase further. And when you do this for y and z, x is increasing, so y is increasing, so y is increasing, so x is increasing, and this becomes a cyclical increase. And they quickly run away to infinity. That is why we need to keep them diagonally dominant. This was a nice question. Okay, thank you. All right, are we ready? Anyone else still not able to get their programs to work? Yes?
Say if anyone can't get their programs to work.
Do you need some help?
Yeah.
Yeah.
So it might
Means you're not fully converged. No, yeah, you're on the way to.
We're 26.
Yeah. Yeah. You don't need.
Most of them.
Just remove names.
It is very different than a Jewish heritage. It takes. It's not.
Yeah.
I mean, take a look, lots of your university. Oh, okay. I got one of the sites. Because I can't believe I said, at least I brought those rights.
You don't assume, you pick it up.
It was sad, like, you just put rights.
That's right. There is no more magic. See, there are no more tricks that I have to teach you. I already told you one big trick. Do the syntax right and it will work.
Yeah. Try to make one.
Last year, in the back.
Okay, so hope all of you have working programs, and I'm just going to pick an example from the book and throw it on the board, and you are going to use your program to solve it, okay? And then check it manually. All right, example 9.12 from the book. I don't know if it's. Let me write it out. So punch in these coefficients and use your program to solve them. Okay. Point 1 x plus 7y plus or minus 0.3 times z equal to minus 19.3. 0.3 x minus 0.2 y plus 10 z equal to 71.4, and 3x minus 0.1 y minus 0.2 z equal to 7.85. Now, in your exam, you would get one problem for sure on this. You will be first given the set of equations and said, use Gauss-Seidel method to solve this, carry out 3 iterations, or carry out until the tolerance or error is below 0.01 or something. Usually 3 or 4 iterations, not like 7 or 8, no. First thing you need to do is to check if this is diagonally dominant. If it is already not, you will have to rearrange to get it to that form and then start your solution. If you just start without checking for diagonal dominance, your solution may or may not converge. Okay, so let's take a few minutes of quiet time, work on this, and then we can start talking. Okay, I'll leave you alone for 5 minutes. 10 z, yes, sorry, 10 times z. I'm going to create a submission portal for this programming assignment. All right, so created a class participation module 2 assignment, which is said to be due not 12:45 AM, like 12:45 PM by the end of this class. But it will be open, it will be accepting submissions until 5 PM today. So I want all of you to try and upload your file either by end of the class or by 5 PM today. Okay? From the next assignment, we'll keep it more real in the sense it will be due just within the class period. But today until 5, you have time to work on this. Okay?
Were you wanting the Excel file or the MATLAB file?
MATLAB file. It says right here.
The online
Upload.
copy accepts the Excel right now.
Oh, okay. Maybe I should change the file types. So I'm going to put .m and yeah, .m file. Try now. So you upload a MATLAB file that implements the Gauss-Seidel method as discussed. Due by 12:45, open until 5. If suppose you're not able to upload after 12:45, feel free to email them to me, but before 5 o'clock. I won't accept submissions that come after 5.
The submission window.
If you're not able to upload, email it to me, but before 5 o'clock.
Yeah, it's working.
Sorry?
It's working.
It works? Awesome. So go ahead. If you have a working code, upload it. Again, we won't be too critical about perfection. It has to work. It has to be a good demonstration that you participated. All right, so let's try using our program here to solve this problem. So as written are these equations in a diagonally dominant form? No. The first equation, if you want to use it as a pivot, which variable would you use it as a pivot for?
Why?
Y, because the coefficient of y is the larger. It's clearly larger than the sum of 0.1 and 0.3. So this is a good candidate to be used as a pivot, not for x, but for y. So this has to be the second equation. If you look at the third equation, what is it? Is a good which variable is the pivot? Z, because clearly 10 is greater than 0.3 plus 0.2. So this is a pivot for Z, which means we want to have it as the third variable, and naturally that leaves only one equation, and that clearly is a pivot for x. So that's the first equation, pivot for x. So step 1 in your exam is you will write as written. These equations are not diagonally dominant, all three. Sometimes one might be a good choice, but the other two might not be. And then you would rearrange the equations and write them. Rearranging. You would write 3x minus 0.1y minus 0.2z equal to 7.85. And then second equation, 0.1x plus 7y minus 0.3z equal to 19 minus 19.3. Third equation is 0.3x plus minus 0.2y plus 10z equal to 71.4. you would now punch in these values into your code. And if this were the exam, you would invert first equation for x, second equation for y, third equation for z, and then do 3 or 4 iterations as mentioned in the problem. When you're doing it in the exam or with hand calculations, I strongly recommend having a table to be organized. Iteration number, x, y, z, error in x, error in y, error in z, and then you will have your defined error criterion to check against the tolerance. So when you start your guess, you have 0, 0, 0, 0 as your initial guess. Okay, iteration 1, you will fill out the value, and then ex is x minus x previous. Similarly for ey and ez, and error, this is what I said can be derived or calculated in many ways. There is no one correct way. In the exam, I might give you an error equation which is say something like this: ex squared plus ey squared plus ez squared square root. This is a possible way to calculate error. Or I might ask you to say, define your own error criterion and state it. You'll have to tell me what you decided and state it and use it for calculations here. This is where common mistakes can be done. For example, you might define error as, say, for example, a simple average of 3 values. What is the problem with that? What is the problem in using a simple average or just the direct value of ex?
If you have one that's giant, so throw off the others.
No, that's not the problem.
The sign.
Sign is the problem. If the sum of these 3 happens to be negative, that is still technically less than tolerance because it is to the left of 0. Your program will abruptly stop. So one pitfall to watch out for is never deal with ex. Always deal with the absolute value of it, either by squaring it and getting rid of the sign, or directly taking the magnitude and using it. Never deal with ex directly. Okay. See, this is why it's important to come to class, because I will say these things many times, but I'm not going to keep writing it down in emails. So email updates won't help. Yes.
I'm having trouble finding it.
Trying to get what?
I'm having trouble finding it.
Determine, I'm not
I'm having trouble turning it in.
turning it. What's the problem?
It's wrong. Let me see the value.
It will accept only .m files, not text files. We'll come to that. So let's put these coefficients and see what our program gives us. I have 3 minus 0.1 minus 0.2 and then 7.85 and 0.1 7 minus 0.3 9 minus 19.3 0.3 minus 0.2 10 71.4. So before I run my program, those who have already been able to run it, what is the answer? X equal to 3, y equal to -2.5, z 7. Okay. All right, let me just see what my program gives me. Oh, cool. So it gives the same 3 minus 2.5 and 7, and it took how many iterations? 5 iterations with our error criterion. With our error criterion. Okay, so now 12:30. Take 2 minutes. Get if those whose programs are ready, go ahead, upload them. And then I want to make a few closing remarks. And you have until 5 p.m. to upload. If you're not able to upload, email it to me, but before 5 p.m. 5:01 doesn't count. Okay. Yes.
I'm getting different numbers, but I plug them into the equations and they work.
It has to have a unique solution.
They're like super close to it. Well, because. What do you mean? For X, I'm getting like 2.9, basically 3. For Y, I'm getting -3, and then for Z, I'm getting 7.
Yeah, 3, -3.
Yeah, but I'm not. My Y is different.
Y is very different. Maybe you made a mistake in the coefficients. That's the only explanation. So, okay, 5 minutes for those who can to upload their programs. And after that, I want to make a couple of remarks, please. Let's focus. So there might be submission issues or still some snags in your program. That's why I'm giving you time until 5 p.m. Next module, there won't be that extra time. You'll upload it in class. Okay. All right. So we did one possible error criterion which takes the maximum of the error values. Now we'll try maybe this error criterion, the square root, the kind of like the norm. It's called Euclidean or norm criterion, where you take the squares of each and add them up and take the square root. Okay, mean squared error. Okay, so we'll write E2 equal to error in x squared plus error in y squared plus error in z squared, and I want to take the square root of the entire thing. And then instead of using error E1 as my error criterion, I'm going to use E2. Don't yet run the program because we are going to build a table. So our first error criterion, number of iterations. What was our first criterion? Max of E1 or EX, EY, EZ. How many iterations did this take? 5. Now run your program. And the second criterion is EX squared plus EY squared plus EZ squared square root. This is taking also 5 iterations. Just for trying something, we'll try absolute value divided by 3, like the average value of the magnitudes of the error. So put E3 equal to it's basically the average of EV. The average of EV. Right? So now you would swap out your criterion E2 for E3, run it, 1, maybe we shouldn't do an average, we should just do sum, because average is you're dividing by 3, that can be misleading. Yep. Just do sum. You're also getting 5 iterations. So in conclusion, the choice of, remember all 3 gave you the same answers, like x equal to what? Like, what was x? 3, 3.000, y equal to 2.5, negative 2.5, and z equal to 7. They all gave the same answer, but in the exam, if I left it open-ended and said pick your own criterion and you picked any one, the effort and the answer, they are almost the same. The only mistake you could do is, of course, calculation mistakes aside, is to use something that involves the sign. If you had used EX anywhere, you're done. That's it. You're done. This, if you made a mistake, suppose by calculation mistake, instead of 2.5, you ended up with 2.3, that would be almost forgiven, like maybe 10% partial, 10% credit might be taken off, like you might still score 90%. But if you do this, you are likely to get something below 50%, because this is a critical error. Okay, so the exam is not to look for these numbers alone, is to look for your methodology, and you have to clearly write it up. You don't write clearly, then don't expect us to reward for things that you didn't do. Yes, there was a question.
I was just saying, so we can include the sign as long as we have the absolute value, or even if we use the second option, because we'll cancel it out.
You have to either use the absolute or use a square, but never the EX directly. That's it. Yeah. All right, so last announcement for the day. I still haven't posted a homework for this topic. I will do it tonight. It will have only 2 problems, one using this method and one using Gauss elimination, which I asked you to self-study. For the exam, which is scheduled next Tuesday, there will be 4 problems. 2 problems from module 1, 2 problems from module 2. Module 2, there are only 2 techniques, elimination and Gauss-Seidel. So you can expect 1 problem on each. Okay, and module 1, there are like 5 or 6 techniques, any 2 might be asked. Okay, so you have to study all the techniques in module 1 and the 2 techniques in module 2. Yes.
So you're gonna specifically ask us which technique to use?
I may or may not. I might leave it open-ended. I can't comment on that. Yeah.
If you get like a really bad derivation one, do you get partial credit?
Of course. Usually the answer will have only 10 to 15% or at most 20% of the total weightage. It's the steps that matter most. 80% is allocated for that. If you are really a genius and you just write the answer and that's wrong, you're done. Because I don't know what went on inside your head and I can't reward you for it. But if you are an average person who can do all the steps but makes mistakes in the end, which are not very consequential mistakes, we will not punish you. We will try to give you at least 80 to 85% of the credits. Yeah.
Do we get to make a formula sheet or anything like that?
Yes, calculator, 1 sheet of notes. Like 1 cheat sheet. Right? 1 sheet. Handwritten, no printed material, only handwritten. You can write both sides. Yes.
When you're doing your initial guess for your Gauss-Seidel method, and you have the zeros, do you want to see all that 0.00?
Yeah. Maintain 4 decimal points everywhere. Period. Yes.
It must be graded before the exam.
No, homeworks are likely not to be graded before exam, but I'll post the solution or I'll discuss it at the recitation session. And you can all watch it. But it's not about, I can give you this problem as the homework. And what I'm expecting to see is, can you do it methodically and document it properly? That's what the homework is about. It's not about the answers. And if I give you this, you have your program, so you can always find out what the answer is. You don't need me to tell the answer. Yes,
So homework's gonna be due this in 2 days.
homework is going to be due before the start of the exam next Tuesday. So you bring your homework to the exam, give it and then take it.
You said you're gonna post the solution, so.
It doesn't matter, I can tell you this, you can post this as your homework and it would, people would still score badly. I'm confident,
You're probably not wrong, it's the worst part.
that's true, I have seen, I have enough data to back up or build my intuition, but of course, you guys will disprove me. You'll make me take back my words, I'm very sure,
Sure.
very sure.
Zero time.
Alright, so that wraps up today on Thursday. We will do more example problems and I also have a recitation session planned. But depending on the number of problems we are able to get through in class, I might not hold that additional session because I'm actually a little bit ahead of my schedule. So I don't need that extra session. All 90 minutes, we can just solve problem after problem on. Yes.
Which one did you want us to submit? Did you want us to submit